move on to Unit 8, which is about statistical analysis and interpretation of assessment results. Those are huge words and sounds very complicated. I will try to make it as simple as possible, although some concepts might seem more difficult than others. This is a very, very important unit in your study guide, and it should be emphasized that you should study this unit very well and make sure you understand. This unit is all about understanding. If you don't understand the terms, the concepts, then you will not be able to do any of the analysis of assessment results. Okay, so basically this unit focuses on analysis of statistical concepts and symbols, organization of test results. It examines methods of organizing results and calculating test results. Outline of the unit, we'll see it goes up to 8.5, and we move on to 8.1, which is about the meaning of basic statistical concepts and symbols. So what is statistics? Statistics is a discipline that can help to resolve problems like making sense out of a large amount of data. We will shortly discuss also the definitions of data and other statistical concepts. These also include variables, graphs, measures of center, measures of spread, measures of shape, and kurtosis. I hope I am pronouncing that correctly. So when we look at data, what is data? Data is facts, observations, and information that come from investigations. There are two different kinds of data: measurement data, which mainly focus on quantitative characteristics or data, and categorical data, which is mainly focused on qualitative data. Okay, so move on to the next one, which is variables. Variables are things that we measure, control, or manipulate in research. It differs in many respects, mostly in the role they are given in research. So the types of variables that one gets are discrete, continuous, independent, dependent, qualitative, and quantitative. Again, I would like to emphasize that you need to know what these terms mean. They go into extensive detail in your study guide. Make sure that you read it and understand it. Graphs are visual display of data used to represent frequency distributions so that the shape of the distribution can be seen. You might be a bit more familiar with graphs, as you may have used them in high school as well. So some of the graphs, typical examples, are the bar graph, the histogram, box plot, and scatter plot. Okay, we move on to measures of center now. Measures of center is basically plotting the data in a frequency distribution to show the general shape of distribution. Statistics used to represent the center or measures of center is the mode, the mean, median, and the mean. I will discuss these three statistics as they are quite important for you as a teacher one day, and you will probably use them quite a lot. But before we go there, we're going to look at the measures of spread. Sorry. So the measures of spread, we see that measures of variability provide information about the degree to which individual scores are clustered about or deviate from average value in distribution. Okay, probably an important word in that sentence is clustered, or how it deviates. Clustered means that all the scores are in one little ball at the same place, or how it deviates from the average value. In other words, the spread is quite wide. So types of measurements of spread are called range, interquartile range or IQR, variance, and standard deviation. The next one is measures of shape. Measures of shape is for distribution, summarizing data from continuous measurement scales. Statistics can be used to describe how distribution rises and drops. So here you can, if you look at the word shape, you can see where rises and drops come in. So some more examples are symmetry, skewness, positively skewed, and negatively skewed. Sorry, I left out the word there. The last one, kurtosis, has a specific mathematical definition, but generally it refers to how scores are concentrated in the center of the distribution, the upper and the lower ends and shoulder of a distribution. These types include mesokurtic, platykurtic, and leptokurtic. Big words. Okay, we're going to move on to the measures of central tendency. And the easiest way to show the measure of central tendency is to use a balance scale. So the measures of central tendency is the point at which the distribution is in balance. So when you look at the little illustration there, you can see these bars on your left-hand side or your right-hand side may represent the scores on the scale, where it forms quite a huge cluster and a bit spread out on the other side of the scale. So when we want to find the point in which the distribution is in balance, if we had to put a weight, for example, to these blue blocks, we can see that just after 6, we will probably find the point where this graph would be in balance. All right. The next one is measures of central tendency. We continue with the smallest absolute deviation. Okay, so the smallest absolute deviation is the sum of the absolute differences. Again, make sure you understand the terms. That will make it easier for you to understand how to calculate these. The graph or illustration at the bottom is the one that's also in your study guide. I have added an extra column just to explain where the numbers come from. So they have chosen the target number as 10, and we look at the values that we have. That's a given. So they give you the values is 2, 3, 4, 9, and 16. Now we're going to look at the absolute difference from the number 10. So if we look at 2 is 8 values or scores away from 10, 3 is 7, 4 is 6, 9 is 1, and 16 is 6. So it doesn't matter if it's a plus or a minus, you just look at the absolute difference from 10. If you count that together, then you get 28, so you calculate that, and the absolute difference from these values is then 28, and that is then called the smallest absolute deviation. All right. The next one is the measures of central tendency. So they explain this as the smallest squared deviation. It's based on the concept of the sum of squared differences. Okay, here again I use the same illustration that is in your study guide. However, I have added 2 columns to make it a little bit easier to understand. So again, we've got the same values. We see that they chose the target number as number 5, and then the squared differences from 5. All right, so where we had 9, 4, 1, 16, which gives us 16 and 121, we're going to work with 5 at the moment. Okay, so in the second column, we see that they gave the number 2. So 2, to get to 5, you need 3. 3 times 3, the last column, gives you 9. The value number 3, you add 2 to get 5. So the 2 you need to square, and that gives you 4. And then 4 plus 1 is 5. So we get a 1 there, and 1 times 1 is 1. The last one is number 9. Minus 4, you get 5. So 4 is your number to square, and there you get 16. The last one, 16. You have to take away 11 to get 5. And 11 times 11 is 121. So just to give you an idea how they got to the square differences from 5, I have added these two columns to make it a little bit more clear. All right, so then the sum that we get is 151, and that would be the smallest square deviation. Sorry. All right, do a few of these. You can choose your own values that you get used to the calculation of these differences. Okay, I'm going to move on to the mean, median, and mode. These are 3 very important statistical terms which you need to know, and you will use them in your practice one day when you are a teacher. So when we define the mean, it's one of the most useful and widely used techniques for making sense out of data. It's also called the average. If you remember that, then the calculation of the mean just becomes a lot easier. So basically, when we calculate the mean, we add up a set of scores and divide it by the number of the scores. This is how you do all types of calculations to find the average. As you will see in your study guide, there's a formula for the mean. So basically, they explain it. The mean is the sum of all data values and divided by the number of the values. So symbolically, and it's important for you to learn this, is the x bar, is that little x with a stripe on top. That is the mean of the set of x values. So that will be the mean, okay, as illustrated above. The funny Greek E is the sum of all the x values, all right? So and n is the number of the x values, all right? Make sure that it makes sense to you. I'm going to give an example now of using this formula for calculating the mean. So say we have these scores or numbers that we have to calculate the mean of, all right? So there's the symbolic symbolic formula for calculating this. So we know what they call the x bar equals then the sum of all data values. In other words, we have 3 plus 9 plus 10 plus 8 plus 6 plus 5, which gives us 41. And we are going to divide this by the number of data values. So the number of data values is, we have 1, 2, 3, 4, 5, 6 different numbers or scores. So we divide it by that. Okay, and when we do that, we get 6.83. So that would be calculating the mean. It is more easy than it sounds. Just get used to the formulas, know the formulas, and the different symbols used for them. All right, we will move on to the median. So when we look at the median, we see that when data is not normally distributed, the median can be used as a measure of central tendency. The median is the point in the distribution above which and below 50% of the scores lie. This simply means that if we arrange the scores from low to high or high to low and find the middlemost score, we have the median. All right, so the median simply means the middle of all the scores, arranged either from low to high or from high to low. An example of the median, we can be presented with the following numbers or scores. There I have 5, 8, 10, 23, 1, 6, 78, and 3. Okay. Now we arrange the numbers from highest to lowest or other way around. So we get 1, 3, 5, 6, 8, 10, 23, 78. Okay, so together we have 8 different numbers or scores. 50% of 8 is 4. In other words, half of 8 is 4. Thus, the median of these scores lie between 6 and 8. We have to find the very middlemost point. So that's between 6 and 8. In other words, we'll be getting 7. So that would be the median. Right. I think that is pretty clear to understand. You just need to make sure that you remember what each of these terms mean. Okay. Moving on to the mode. This is the last one. Sorry. The mode is the most frequently occurring score or value. In other words, the score or value that shows up the most in the ranges. Okay. So an example of that is if the values that you have is 5, 7, 6, 9, 2, 5, 1, 6, 5, 8, 10, 12, and I arrange them from low to high, I get 1, 2, 5, 5, 5, 6, 6, 7, 8, 9, 10, 12. So I can clearly see from this arrangement that the value that most frequently shows up is that of number 5, and that's the mode. Also quite simple to explain. All right. We move on now to the degree of difficulty of test terms. It is relatively easy to determine the level of difficulty of individual test items. So say you have one of your questions in your question paper and you want to determine the level of difficulty of that individual test. You can use the formula where you divide the number of learners who answered an item correctly by the total number of learners who answered the question. Okay. And then you multiply that figure by 100. So basically, if we look again at the symbolic representation of that, it would be x divided by the number of learners who completed the question. So x is the ones who answered correctly, and then times it by 100. Okay. The example I have there is, say you have 10 learners who answered, say, question 3 correctly, but 20 learners answered the entire question 3. So then you take 10 divided by 20, that would give you 0.5 times 100, and you get 50%. So that would be the degree of difficulty of your test terms. Normally 50 is a good degree to have. Okay. 8.5 is the differentiation or discrimination value of test terms. So again, some big terms here. Make sure you understand what each means. The discrimination index or item effectiveness is a kind of correlation that describes the relationship between a learner's response to a single question and his or her total score of the test. Okay, so this is where things would differ. A learner has scored extremely high in 4 questions and then extremely low in 1 question. So then we look at the relationship between those responses of that specific learner. These statistics can tell you how well each question was able to differentiate amongst learners in terms of their ability and preparation.